Prime numbers do not follow a simple repeating rhythm. Along the number line, their gaps change and their distribution becomes gradually thinner, but place consecutive integers on a square spiral, mark only the primes, and diagonal structures appear across the image, the program has not discovered straight lines hidden inside a list of primes, and it never draws a diagonal line. It emits one SVG circle for each prime. The spiral arrangement makes particular arithmetic relationships spatially adjacent, allowing prime-rich and prime-poor tracks to become visible. We will follow the complete released C++20 implementation, how it walks the grid, computes primality, maps integer coordinates to SVG, and proves its min paths with focused tests. Every code reference belongs to the immutable public tag artifact 002 version 1.0.0. Start with value 1 at coordinates 0, 0. Value 2 moves one cell to the right. Turn upward for 3. Continue left for 2 cells, down for 2, right for 3, and upward for 3. The segment lengths follow 1, 1, 2, 2, 3, 3, increasing after every 2 turns. The code stores exactly the state needed for that walk, x and y, a direction vector dx and dy, the current segment length, progress along that segment, and the number of completed segments at the current length. Advance first adds the direction vector to the position. If the segment is not finished, it returns immediately. At the end of a segment, progress resets and the direction rotates. The old horizontal direction becomes the new vertical direction with a sign change. In SVG coordinates, where y increases downward, that produces the intended right, up, left, down cycle. After 2 completed segments, the counter resets and segment length increases. This small state machine generates the expanding square without storing a grid of coordinates or deriving a separate closed formula for every cell. The optional cells parameter stops the traversal early, while show values prints the integers. Together, they let the production renderer explain its own construction before the dense prime field takes over. Before drawing, the program calculates primality for the entire requested range with the Sieve of Eratosthenes. It creates a Boolean entry for every value from 0 through the maximum, initially marked true. 0 and 1 are then explicitly marked non-prime. Starting with factor 2, the outer loop considers possible prime factors. If a factor has already been marked composite, it is skipped. Otherwise, the inner loop begins at factor squared and marks every multiple as composite. The outer condition deserves attention. Instead of asking whether factor squared is less than or equal to the limit, it asks whether factor is less than or equal to limit divided by factor. Those statements are equivalent for positive integers, but the division form avoids overflowing during the bound check. Only after the safe condition succeeds does the code form factor squared. Side length squared gives the number of cells. Add that count minus 1 to the center value to find the maximum integer. The program checks that this maximum fits the platform's address space, then builds one sieve covering the entire range. For maximum value n, this implementation uses order n bit through vector bool, and the sieve takes order n log n time. The latest spiral walk is linear in the number of visible cells. The spiral cursor produces integer grid coordinates. The renderer must turn them into canvas positions. It takes the shorter canvas dimension, removes the chosen margins, and divides the remaining extent by the odd side length. That value is one cell size. Dot radius is a fraction of the cell size. Canvas width and height can change, but using the shorter dimension keeps the grid square instead of stretching the mathematics. Each loop index becomes the center value plus that index. A direct lookup in the sieve answers whether it is prime. For a visible prime, x is canvas center plus cursor x times cell size. Y uses the corresponding cursor y. The renderer writes an SVG circle at that position. Composite values are normally absent. If composite opacity is greater than 0, the same loop emits them in a separate color at low opacity, exposing the square lattice beneath the prime pattern. Labels are another optional teaching layer. Finally, the cursor advances exactly once, ready for the next integer. Side length is structural. An odd side places one cell exactly at the center and completes symmetric square shells. Increasing it from 21 to 101, 501, or 1001 expands the number range. At fixed canvas size, dots become smaller and long diagonal textures become easier to compare. The start value is also structural. It chooses the integer at coordinate 0, 0. Changing start from 1 to 41 does not translate the same picture. It assigns different integers to every coordinate, changing which arithmetic tracks cross the view. Radius is presentational. It changes sparse dust into heavier marks, but leaves primality and position untouched. Composite opacity reveals traversal context. Too much reduces prime contrast. Margin controls breathing room, while palette changes viso hierarchy without changing a value. The diagonal streaks are not evidence that primes have become periodic. Straight tracks through the spiral correspond to quadratic expressions in their step index. Some such polynomials produce primes more frequently over a particular finite range than neighboring tracks. The spatial arrangement makes those differences available to the eye. Reproduction requires cmake 3.20 or newer and a C++20 compiler. The renderer has no graphics dependency because it writes SVG markup directly. Check out the immutable tag, configure, build, and run the featured command with side 501, start 1, and the documented margin and dot radius. The release registers 3 tests. The smoke test renders side 101 and expects 1252 primes. The negative test verifies that even side 100 is rejected. The labeled construction test draws the first 25 values and expects 9 primes from 1 through 25. There is no randomness. For identical parameters, integer traversal and fixed 3-decimal SVG formatting produce deterministic vector output. Different rasterizers can still vary slightly along anti-aliased pixel edges, but the SVG geometry and values remain reproducible. The complete image comes from 4 cooperating ideas. Side length defines an integer range. The sieve classifies every value. A compact cursor places those values on an expanding square. The render loop emits circles for the primes. No diagonal is explicitly encoded. The visible tracks emerge when a one-dimensional arithmetic property is reorganized in two-dimensional space. That is what makes the Ulam spiral both a mathematical diagram and a compelling generative artifact. The exact code, parameters, tests, and references are available in the public repository. In the next episode, we will move from prime positions to the structure created by divisor counts.